To understand prime factorization, we first need to understand what a prime number is. So even though this is not a formal definition of a prime number, you can think of a prime number as being a number that can't be divided anymore. If we take a look at the number 8, 8 can be split up into two numbers. It can split up as a multiple of 4 and 2. That means 8 is not a prime number because we can divide it up into multiple values. But a number like 7 cannot be split up anymore. So this is considered a prime number. If we look at the number 15, can 15 be divided by any number? Well, yeah, it can be divided by 3 and 5. Because it can be divided by 3 and 5, it's not considered a prime number. So let's consider one more number, like the number 11. 11 cannot be split up into a multiple of two other numbers. So we say that 11 is considered to be a prime number. So in the examples here, the number 7 and the number 11 are both considered to be prime. For these problems, they basically want us to take a number and break it up as much as possible. So this problem tells us write 72 as a product of prime factors. So we always start these problems by figuring out what times what will give you 72. Right now we're at 72. What if we break it up? What times what will give me 72? Well, one combination would be something like 8 times 9. 8 times 9 does give us 72. The problem with having 8 and 9 is that we don't have prime numbers, and the prime numbers is what the problem wants us to have. So we got to break up these numbers up too, if it's possible. What times what gives you 8? Well, 4 times 2 gives you 8. What times what gives you 9? Well, something like 3 times 3 would give you 9. If we look at the values we have now, we'll notice that 4 is not a prime number. We can still split 4 up into two values. We can still split up 4 into 2 times 2. But looking through our other numbers, we have a 2, a 3, and a 3, and neither one of those numbers can be divided any further. Since we split up the 4 into both of these 2's, all of these numbers are going to be part of my answer. So my final answer is literally going to be 2 times 2, and I'm looking at these two right here, times this other 2, times a 3, times one more 3. This entire expression will be my answer to the problem. So the idea behind this answer is that all of our numbers are prime numbers. And if we take their product, if we multiply all of these numbers together, we end up getting 72. If we want to double check it, 2 times 2 is 4, times another 2 is 8, times 3 is 24, times another 3 will in fact give us 72 as an answer. For this problem, we have 66, and we got to figure out, can we split this up? What times what will give me 66? Well, 11 times 6 will give us 66. Can we split 11 up? No, we can't divide it any further. So I went ahead and circled it because I know that's going to be part of my answer. We can't simplify that 11 anymore. But we can split this 6 up. We can split the 6 up into 2 times 3. Can I split the 2 up any further? No. Can I divide the 3 any further? No. So my final answer is going to contain 11, 2, and 3. Technically, the order in which we write these numbers doesn't matter, but typically you'll see it written in chronological order. So starting with the smallest number, we have 2 times 3 times the largest number, which in this case is 11. So this will be my final answer to the problem. This problem starts off with 52, and they want us to split this number up as much as possible. Now this number is a bit tricky because it doesn't really use the multiples from 1 through 12, at least not at first sight. It turns out that 13 can be divided into 52. So 13 times some number is going to give us 52, and that other number is a 4. I don't believe this section allows you to use a calculator, so this does take a bit of thinking to get down. And 13 times 4 does in fact give us 52. So if we continue the problem, we try to break up both of these numbers up again. For 13, we can't divide it any further, so we know that that's going to be part of our answer. But 4, we can split up into 2 times 2. And these two can't be divided any further. So our final answer ends up being 2 times 2 times the 13. For this last problem, we have 88, and we need to split this 88 up into a multiple or a product of prime numbers. So what times what gives me 88? Well, we know that 8 times 11 gives us 88, so we can start there. Can we split up 8? Oh yeah, we can split it up into 4 times 2. Can I break this 11 down into two numbers? Well, no, so we know that's going to be part of my answer. Going back to the 4 and the 2's, we can split up the 4 into a 2 times 2, and we can't split those up any further. And this 2 that we have up here, we can't split up anymore, so we need to make sure we keep that in our final answer. So now we have 2 times 2 times 2 times 11 as the answer to the problem.